Hello, today we are here to present a video presentation ISC activity of Computer Organization and Architecture. I am myself Amruta Vijay Desai from CSC SYA division. Today my roll number is 2058. Today we are here to present video presentation and my presentation topic is page replacement policies. The page replacement policies are FIFO, LRU and optimal. Let us see the FIFO, LRU and optimal page replacement policies in details. Now let us see the introduction to page replacement policies. In introduction we will see the key points of page replacement policies that are managing memory, page faults, efficiency goal and policy impact. In managing memory, page fault helps page replacement policies helps in managing memory because when we have a small memory size, we can take the page from external memory or a hard disk and page fault means when a process requests a page that isn't in the memory, then page fault occur, and for page fault we can use this page replacement policies. Then efficiency goal. The efficiency goal of page replacement policies is to minimize the page faults. And policy impact. The choice of page replacement policy directly impact to overall system efficiency and user experience. Let us see the first type of page replacement policy, that is FIFO. The full form of FIFO is first in, first out. As per the name, in this page replacement policy, the first page which arrives in the memory is replaced the first, and this leads to high inefficiency, higher page fault rate. That is why it is not more efficient than other two policies. Let us see the next two policies. We will study the FIFO page replacement policies example. That is the frame size of the memory is given, that is 3. That means we can store only 3 pages at a time in the main memory. The reference string is given, that is 73213021446. It is the page number of the pages. When we put a page in a memory, that is means when we put 7 in the memory, we have no pages before in the memory. So when we put in the memory, it is a page fault. So we write here F. Now 3. We have to put 3 in the memory, but we have 7 earlier in the memory. So we write here 7 and here 3. Then it is also a page fault because we put page from outside. So we write here F. Then 2. 2 is also not in the memory and we have to write it here. So it is also a page fault. We write F here. Now we have to replace the page because the memory is full. We have only 3 frames. That is frame 1, frame 2, frame 3, and the frames are not free. So we have to replace one of them. And in FIFO, we replace the we replace the page which first came in the memory. Here 7 came first in the memory, so we replace 7 and put 1 here. So 1 is here and the 3 and 2 similar to before. Then we have replaced the page, therefore it is also a page fault. Now 3. Here we have 3 in the memory already, so it is not a page fault, it is a page hit. So we write this same similar and write here H, that is page hit. Now 0. We have to replace the page because 0 is not present in the memory. In this memory, the second means after 7 3 is came, therefore 3 is replaced. Therefore 1, 0, 3 and here a page fault. Now it is 2 and we have already 2 in the memory, therefore we don't have to replace it, therefore it is 102 similar to before and it is a page hit. Now 1, we also have 1 before in the memory, therefore we don't have to replace it. Now we can write it similar and write here page hit. Then it is we have 4 and we don't have 4 in the memory before, therefore we have to replace a page and here is 2. Here we will replace 2 because 2 is came first before 1 and 0, therefore 2 is replaced and 4 is put here. This is similar 1, 0 and it is a page fault because the page is replaced. Here also we have to replace the page because 6 is not present in this, and we will replace 1 because the 1 came in the first in these 3 numbers. numbers. Therefore, 1 is replaced 604. It is a page fault. We have to calculate the page faults and page hits. It is page fault and page hit. Here page faults are 1, 2, 3, 4, 5, 6, 7. There are 7 page faults and 3 page hits. LRU. The full form of LRU is least recently used. In least recently used policy, it keeps the track of most recent pages and replace the page which is least recently used. In this, it improves the performance by reducing the page faults, focusing on the process actually used. So it is better than FIFO, and least recently used as it track the most recently used pages, the implementation complexity is increased. Now we will study the LRU policy. We have taken the same frame size of before example, that is previous example, that is of FIFO, that is 3, and the reference string also same. Now we will see the difference between that example and this LRU. Here similar to that example, 7 comes here and it is a page fault. Then 7 remains here and 3 also comes in the memory, that is also page fault. Then here 7 come here, 3 also come, 3 is already here, and 2 comes in the memory, it is also page fault. Now we have to replace this 3, one of these 3, because we have to put 1 in the memory. Now it is a question that which page we should replace. Here we have to replace the least recently used. Means here 2 is the most recently used. Then after that 3 is most recently used, and then 7 is most recently used. That is, it is a least recently used page. So we have to replace 7. Now we will replace the 7 with 1. 1, 3, 2. Now we replace the 1, and it is a page fault because we have replaced the page. Then 3. We have 3 in these numbers. Therefore, we don't have to replace the page. So we write these pages as similar to before, and it is a page hit. Now we will check next number. We have to put 0. We have to replace a page to put 0. Now it is question which page we should replace. Now we will check at the left side which is least recently used page. It is 3 is most recently, then 1, and then 2. So we have to replace 2. We will put 0 here at the place of 2 and write 1 and 3 as before. It is a page fault. Now 2. We have to check, we have to put 2 in this memory. Now we will replace the least recently used page. That is 0 is most recently, then 3. So we have to replace 1. Then we will put 2 here and put 3 and 0 as here. It is a page fault. Then we have to put 1. So which page should be replaced now? It is a 3. We will replace 3 and put 2 and 0 as before, and it is also a page fault. Now for 4 we have to replace 0 because 1 and 2 is most recently used. Then we will replace 0 and put 2 and 1 as before. And for 6 we have to replace 2. 6, 1, 4. It is also page fault. The number of page fault here is 9 and the number of page hit is 1. Now the optimal. In optimal, the page is replaced. The page in future we will not need recently is replaced. Now we will study the optimal page replacement policy. Here similarly we have used a frame size 3 and same difference string. Now firstly 7 is put in the memory. There is no page, so no replacement happens, and it is a page fault. Now we have to put 3. So 3 is placed here, and it is also a page fault. Now for 2 it is placed here, and it is also a page fault. For 1 we have to replace a page. Which page we should replace now? We will check this from first we check with these 3 numbers. This is 7, 3 and 2. We will check which page is not most recently used in the future. That is, we will check the right side of the screen. we need 1. 3 is not needed most recently, so we can replace 3. So 3 is replaced for 0 and 1, 2. It is a page fault. Then for 1, no, for 2. For 2, here is a page hit because 2 is present already in memory. So it is a page hit. It is a hit. Then for 1 also present in this memory. So 1, 0, 2. It is also page hit. Then for 4, we have to replace a page that we should replace any page because no page is needed in the future. So we will replace the first page. Which is first page here? It is 1. So we will replace 1, 4, 0, 2. And it is a page fault. And for 6, now we will replace 0, 4, 6, 2. It is a page fault. Now the total page fault is 1, 2, 3, 4, 5, 6, 7. It is 7 and it is a 3. And for optimal is the base page replacement policy, but it is not impractical because we have to know the future pages which we cannot know before coming in the memory or in the C. Thank you. Now let us see the comparison of FIFO, LRU and optimal. This is policies FIFO, LRU and optimal. The page fault rate of FIFO is high, LRU is moderate and optimal is lowest. Then in comparison of these three, and complexity of FIFO is low, LRU is medium and optimal is high. Factors influencing page replacement policies. The factors influencing page replacement policies are memory size, process size and page access patterns. Memory size. When we have a larger memory, it reduces the page faults because more pages are held by the memory. In process size, if the size of process is more, it has higher page fault because it needs the more memory, and the page access patterns are like sequential access can lead to fewer page faults. Now we will conclude our presentation. In conclusion, we understand the page replacement policies. It is very important to understand the page replacement policies because it is crucial for optimizing the system performance. For example, when it is very important to manage the memory because when we use these policies, we have to know about it so that we can use the optimal policy.